We actually see a plane. I mean, if you raise up your head and see the plane moving, you hardly find any of its maneuvers. You only see the plane moving straight up, right? But more importantly, the plane has got almost like six rotational movements and three lateral movements, three linear movements, which actually is maneuvered by the pilot intelligently to go through the environment which is in. I mean, the sky with a lot of turbulence in it. The atmosphere is not as good, I mean, not as ambient as we see on ground. And the maneuvers that happen there, I mean, maneuvers that the plane has to go through is pitching, is something like it has to, the plane will take up in its loads, its plane will take up its loads. 1 minute, just give me a minute. Yeah, the plane has to, go back and forth. I mean, moving the nose up and down, that is pitch, about the lateral axis, and the vertical axis, and the vertical axis is yawing, turning the plane sidewards, and rolling. While it takes a turn, it has to bank, so the plane rolls about its axis length of the plane. Right? All these movements of the plane will definitely induce a lot of forces. So the structure becomes more crucial and essential when air vessel is airborne with so many passengers in it. Okay, I mean, just to cut this off, all these forces what you have seen are nothing but tension, compression. All these are basic loads that happen. Like, you can just say that the plane gets elongated or buckled or twisted, or the surfaces of them, the skin surfaces of the plane is subjected to tear and bend. Yes, it happens. But we don't find that these significantly because the design takes care of all this, right? Okay, let's go to the desirable material, the desired material properties of an aircraft. I think we know most of these physical properties. The toughness of the aircraft, right? Sorry, the toughness of the material, what we use in the aeroplane. It's very important. Like, as I told you, the forces acting upon these surfaces tend to shear the surfaces, right? Rip the wings off. I mean, we definitely don't visualize that magnitude of forces acting on the surfaces, but yes, that's why there is a lot of toughness required for the material what we choose for an aircraft structure. Strength of the material, I mean, it should resist to deform and stresses also. I mean, we know this. I mean, it's not just about the aeroplane. It's about any equipment or any vehicle what we drive. And more importantly, there is a slight difference for an aeroplane and for the vehicles that move around in the ground. The basic difference is we are actually looking at a structure flying at a very high altitudes of 3,000 to 4,000 kilometers high. And so when we are actually flying a plane at such a high altitude, we see very importantly about the strength of the material, what we use in structure, toughness of the material, what we use in structure, but also the density. The density actually defines the weight of the material, right? So the density defines the weight of the material. And also, we need a material which is strong. We need a material which is of lower density. So it means to say that the strength, we need enough strength to take all these forces of the structure. And also, we need a lighter material to fly the air, to fly the aeroplane, to fly the aircraft, consuming lesser fuel. So what happens is the strength mass ratio is very critical when we are selecting material in an aircraft structure. I mean, it is so logical for us, like, when we fly, we usually look at the commercial aspect, like we need to get lesser rate. Similar way, lesser rate of ticket or buying a ticket at a lower cost. So similar way, the operator of the plane will look at the fuel consumption cost. When we use materials with low density or use materials with low weight, having enough strength to take care of all the forces on the structure, then it's the best thing that can happen. He can encash on the fuel. There will be less fuel consumption when you have lesser weight. I mean, when the strength mass ratio goes high. Right? Elasticity. I mean, there are some areas of this surfaces which actually areas of this aircraft structure which actually go through movement every time, like flaps, as I said, wing flaps. And there is a lot of shattering happening. There is a lot of turbulence in here. There is if the climate is worse, you might have thunders. And when it goes through a cloud, there is a huge pressure difference. So the shattering, and if there is the force, if the forces on the material are withstood, or if the forces on the material don't yield, I mean, yield the material. For example, if you have a flap and it is subjected to the forces, it is subjected to the external forces, and if there is enough elasticity in the material, then the member sustains its shape and position, right? So, and again, thermal expansion is very important when it comes to the materials which are besides the propellers. Propellers go to a very high temperature where the structure has to be retained and the propellers to be in position and functioning, and the plane should be flying. Right? Similarly, the material should have desired chemical properties too. It should have less corrosion. How many times you have seen a plane flying and there is a rain upon it? Yeah, the planes also flew in rain. So we definitely don't get into rain, and we definitely don't tend to put our devices or anything as such into water. Why? We know that our devices or our equipments are made of corrosive material or electronics or something like that. Right? So we need, when we actually have our plane flying in a humid or a wet environment, we need a non-corrosive material. So we need corrosion resistant, right? And thermal stability. So what happens is, so there is a propeller which is attached to the wing, and the propellers are at a very high temperature, and the structure is holding the propellers. Just imagine the structure is also conducted with the same temperature. There is a huge temperature difference between the between the other side of the wing and the propeller portion, there is a huge thermocouple there. I mean, which actually tends, tends the plane to, tends the plane to have, warp, or with the different material, different thermal conditions, it might give adverse effects. So we should have a material which is thermally stable, like titanium. Titanium is a very good example for that. Okay, these are the basic materials what we use, right? Aluminum alloy 2024, which is conditioned to T3, solution heat treated, cold worked, and naturally aged. This is basically used on wings, because it is corrosion resistant, and it is stable. And these are basically used in ribs, spurs, and stringers, as the design calls. And the other common material is common aluminum alloy, which is used as aluminum alloy 7075 T6. All these aluminum material what we use have got their own designated combinations, alloy combinations, and also there are specifically given with the conditions of the material. Usually it is like T3 or T6. Like in case the second material is aluminum 7075 T6, which is used for wing skins, panels, and covers, right? And the aluminum, the condition is like solution heat treated and artificially aged. And these days, I mean, see, as I told you in my previous slides, that we're looking for a material which is lighter and caters the required strength, toughness, and all the physical properties required, thermal stability, name it, all the properties required on the plane, but at a lighter weight. FRPs, I think you might have heard this word, fiber reinforced plastic, which are made out of glass fiber or carbon fiber as per the required design. Kevlar is also used for that. This is a new technology, upcoming technology, which is hugely used. I mean, you can see that. I mean, in Boeing 777 Dreamliner, it has reduced the weight of the plane itself by around 620 I mean, the reduction of the plane is by almost 30%. I mean, if you see the plane is made of many composite materials, up to 70 to 75% of the entire plane structure, right? Okay, let's talk about the fasteners. I mean, all these structures are nice. All these structures are fine. All these structures are supposed to be joined somewhere. How are we going to do this? There are varieties of fasteners that have been invented, that have been used in these aeroplanes, in these aircrafts. And they are designed in a purpose that they shouldn't be affecting this functionality of the surfaces and structure. And as well, they keep the surfaces or the structures intact to safeguard all the equipments, all the systems, and all the passengers and the crew members safe. It is very much important for anyone, for that matter, for anything for that matter. If the plane, if an aircraft is airborne, it is to say that the entire aircraft is flying. If there is one bolt, losing, or one bolt, letting itself out, one bolt broken, is going to bring down all entire aircraft. There are many types of specific types of fasteners we use, and few of them are like we usually go for temporary fasteners in intermittent assemblies. Also, we use permanent fasteners, high locks, high shear locks, rivets, and all rivets of many types, and it is specifically more like that. Like you might have seen the bolts tightening with the nuts to join any of the mechanical members. But there are few fasteners when we use the hexagonal or the surface, the gripping head. Once we tighten the entire gripping head, we after attaining the required shear, required torque on the fastener with on the design, the head rips off. That's called a shear lock. That is called a shear lock. Just to give you a heads up. There are varieties of fasteners used in different conditions and different materials. And it's not just about the few materials what I spoke. The aircrafts are integrated. The aircrafts are integrated using many different materials. There are few steels also used in there. There are a lot of aluminum alloys used in there. Now the design insists for FRPs and also titanium wherever the heat source is around, like propellers. Right? So thank you for listening me. Before we take up this questionnaire, I would like to just give you a brief account of the topic just I completed. This aerospace domain is growing very fast. And if you see that it's a booming place where the booming sector where the entire industries are moving in. All the automotive industries, all the other industries which were in mechanical fields are having their own handlers. I mean, what I'm trying to say is this is a very important topic as a structural aerostructures for people who are looking out to look for in growth or career into these fields.